Hi, welcome back. My name is Owen, and I'm a product manager on the Chrome team. I focus on making sure that all the browsers provide you all of the capabilities that you need to be successful on the web. So I'm thrilled to be here today, joined by Aditya Punjani from Flipkart, who worked on the amazing Flipkart Lite progressive web app, and by Nate Schloss from Facebook, who worked on their service worker-based push notification implementation and is now working on rolling out more service worker features across the site. So our goal here today is to make sure that you leave with all the knowledge that you need in order to bring service workers into production at scale. And to start, I'm going to quickly recap on how service workers can be used to solve a number of key use cases on the web. So the first is caching with service workers. So service workers give you full programmatic control of the network and of your caching. They're a kind of event-based web worker. And the way it works is when a user first goes to your site, what happens is a service worker can be downloaded by the browser and stored on the device. And then whenever any network request is made by your app, like an AJAX request or you include some kind of image, the first thing is that an event is fired into this service worker that essentially allows it to intercept that request and handle it programmatically. It can do this by forwarding it onto a web server, or by reading from a cache, or by generating a response entirely. And so these allow you to build an experience that's responsive and reliable regardless of the network conditions. So next, synchronizing with a service worker. So service worker has this great capability called background sync, which means that if a user takes an action in your app, whether they're on a flaky network or completely offline, you can be sure that that action will make it up to the server. And so the way this works is when a user, for example, writes a post or takes an action that generates an analytics event, which here is represented as the blue dot, even when the web server is not available, you can make that network request. The service worker receives the request, intercepts it, and sees that there's no web server available. It can now register for an on-sync event, which will be fired the next time the device connects to the internet. So now the user can navigate away from the page, they can close it, they can be doing something else on their phone, and the service worker can go to sleep. So now nothing is running. But then at the point where the internet connection comes back, the operating system will notice, it'll let the web browser know, the web browser can wake up the service worker and fire the on-sync event. This allows the service worker to run and you to synchronize your data up to the server reliably and in the background. And finally, push notifications with service workers. And so this starts by you tell your service worker to subscribe to a push server. The push server will generate an endpoint and some encryption keys. The endpoint is kind of like a magic URL that if your backend sends a request to it, it will trigger an event to be fired on the user's client in the service worker. And so the push server generates this endpoint and the encryption keys and passes it to your service worker. Then you send those up to your web server. At this point, the user can navigate away, Chrome can be closed, they can be doing something else on their phone, and then when you have a notification on your server that you want to send to the user, you simply encrypt it with the keys that were given to you, and you make a request to that endpoint. That will pass the data, the encrypted data, over to the push server, which will in turn wake up the device and send an event into your service worker running in the background. The service worker then receives this decrypted payload down from the web server and can use the notifications API in order to show that notification to the user. And so together, Service Worker allows you to build advanced caching that makes your website fast and reliable regardless of the network condition. It allows you to build offline and background synchronization, and it allows you to send your users push notifications. And so together with these capabilities, you can build a really great experience. And so we added one more thing to it, which is add to home screen. So by providing just a small JSON manifest with some metadata about your app, icons, and its name, you're able to show a banner to your users, asking them if they want to add the progressive web app to their home screen. And if they click it, then they get an icon on the home screen, just like any native app. And together, sites that use these rich service worker capabilities and add to home screen, we call progressive web apps. And so the world today looks something like this. You have this array of ingredients that you know can be combined together to build something, to create something amazing. And you might have even cooked up a little something at home and got a taste of it, and you think it's great, But it turns out that, as Rahul mentioned in the keynote yesterday about the mobile web, service workers are now handling over 13 billion page loads a day and are responsible for delivering over 10 billion push notifications every day. And so suddenly you're not just cooking for yourself, you're cooking for a pretty large group of house guests. And so that's why I'm thrilled that we have here today two of the world's master chefs in service worker cooking. And so I'd like to invite up to the stage Aditya from Flipkart to tell you more.
Thanks, Owen. It's great to be here. My name is Aditya, and I work for Flipkart, which is one of the largest e-commerce retailers in India. Now, in India, if I can get my slide to change. All right. Mobile is profoundly important, and it's at the crux of everything we do. At Flipkart, we continuously strive to build really compelling and delightful mobile user experiences. And in that regard, early last year, we actually shut down our mobile website and directed our users to download the native app, which we believed gave a far more superior experience than the mobile web back then. At the same time, we actually asked ourselves, what is it that gives native apps an edge over the mobile web, especially given the unique properties of mobile web, such as an always updated distribution and a frictionless instant load? We identified three core areas, and that is high performance, an immersive experience, and the ability to re-engage our users. Let's look at high performance. There was a common feedback among our users that the native apps somehow felt faster than the mobile web back then. What they really meant was that the native apps had a reliable and consistent performance independent of the network conditions or the type of device profile they had. Mobile networks have a lot of variations to it. You have things like the time of the day, your location, or the number of concurrent users. All of these factors can affect the quality of your network. Take, for example, when you have a low signal. Here it shows that I do have an internet connection, but in reality, I don't. Or what happens if your internet stops working and has just decided to reconnect at some point? Or if you totally lose your signal at all? In all these cases, the native apps seem to endure the network conditions and open up reliably even so. On the web, we have actually lacked the model to build web apps that can endure flaky networks. Native apps, however, do this at a very high cost. On a 2G connection, it can take several minutes for a user to download and install the native app. Compare that to the different ways of building web app at Flipkart. Even with server-side rendering or a client-side single-page app, it takes several seconds before anything meaningful is painted for the first user. On repeat visits, native apps have a significant advantage. On the first visit, they have managed to package and download the entire set of critical resources required for an instant load the next time. We wanted to bring this instant load model to the web. And the way we do that is with the app shell architecture. The app shell architecture is in many ways an evolution of the traditional the server-side rendering or the isomorphic or universal, as we call it. But it has key differences to it, which I'll get to in a minute. For us, the app shell architecture meant breaking down our entire application into two states, a loading state and a loaded state. The loading state is essentially what the app shell is. It's an HTML structure which has placeholders and acts as a host for the dynamic content to come fill in. A well-designed app shell would give visual cues to the user of what to expect as the data loads in progressively. This will enhance his perception of speed. Now, with app shells, you throw service workers to the mix, and you can cache these app shells on the first visit, and on the second load, you have instant load performance. Now, you may argue that we could do this with other technologies, such as App Cache. What is so special about service workers? Well, for us, service worker is a highly programmable low-level primitive. What that means is there is no magic. Everything is left up to us as developers to design the solutions. And with that, we could actually devise very sophisticated cache policies that could never be done before. The last important bit is that the service worker acts as a network proxy layer in your browser. What that means is that our application can be completely indifferent if whether a service worker exists or not and just function with or without it. The impact of this was immense. Even on a 2G connection, we brought down the load times to a few ms thanks to service worker cache. So now on a repeat visit, with service worker and the app shell architecture, we have a comparable load time to the native apps. And it's not just blazing fast, it's even reliable on flaky networks. This is what we believe is the offline first pattern, which is you respond to all the critical resources from the offline cache first and go only to the network for dynamic content that cannot be otherwise cached. This allows us to build really reliable and network resilient web apps. All right, so let's compare the app shell architecture to the traditional way of doing server-side rendering. Now, server-side rendering is a recommended approach to improve first paint, but we get the same benefits for the app shell architecture because in both the cases, we are executing JavaScript on the server and generating HTML for a quick first paint. The interesting thing about the app shell architecture is that the app shells are just static HTML pages. That means they have no dynamic elements to it, which means they could be generated during your build time. So you can offload all the heavy lifting to your build process rather than on the server-side rendering where you have to process and generate it per request. Again, being static, they can be easily cached on the client side, which may be tricky to do with the server-side generated HTML pages because they have dynamic elements to it, so you might end up with stale content, which in e-commerce is unacceptable. The best part about app shell is a single app shell can be reused across millions of URLs of the same time. At Flipkart, we have a catalog of over 30 million products. That means 30 million unique product page URLs. But we can share the same product page app shell across all these product page URLs. The last part is SEO. A lot of users do server-side rendering to solve for SEO. But with experiments at Flipkart, we have managed to achieve the same benefits of SEO with the app shell architecture. There were many challenges that we faced throughout this whole journey. But one of the biggest challenges was maintaining and scaling the handcrafted service worker code we wrote as more team members collaborated on the same file and our use cases grew complex. We found the need to sort of abstract the common patterns and move to a library. We chose to use SW Toolbox. For those who are not familiar, SW Toolbox is a wrapper library on top of Service Worker. It allows you to explicitly define routes and map different caching strategies to these routes. Here's an example of what the code looks like. On the top, you see a product page URL mapped to the sw.faster strategy, which is essentially a race between the cache and the network, most of the time won by the cache, of course. But it also means that in the background, if the network request succeeds, it is going to update the cache with the latest version of the product shell. Service Worker Toolbox also adds a bunch of capabilities on top of service workers. For example, the max entries that allows us to have an LRU-based cache implementation so we don't bloat the cache with too many resources. Max 8 seconds allows us to easily purge cache after a given time. The network timeout second option enables us to build network-resilient web apps by falling back to cache if a request on the network is taking too long. One of the patterns that we followed before deploying service workers to production is to devise a service worker kill switch. The kill switch is essentially a combination of 4 different things. The first is the 2-level versioned cache names. Second, the no-cache HTTP headers. And the third is skip waiting along with clients.claim in the service worker. The way we name our caches is that we have a global version and then a local version appended to the canonical cache name. In the install event of Service Worker, we clear out all the caches that are not part of this cache object. So that means if we had, in case of an emergency, to purge all the caches, we would just increment the global version. And if, for some use case, we had to just bust one particular cache, we would just increment the local version. Now, we want to make sure that as soon as we update our Service Worker file, it reaches the user. So we set the no cache and max age cache control header and a negative expires that makes sure the browser always downloads the latest Service Worker file on every navigation. Now, like us, if you're worried about the amount of download that adds for users on low mobile bandwidth, well, you can add the last modified or the e-tag header and respond with a 304 not modified so that it's only downloaded when the service worker file changes. All right, so now once the browser has the new service worker file, it will install it. On the install event, we want to make sure that this service worker immediately moves from the install state to the activate state. So we call self.skip waiting. This will make sure that the service worker goes to activate state without requiring a navigation from the user. On activate, we want to take control of any and open clients under the same scope of the service worker, so we call self.clients.claim. All these patterns put together allows us to confidently and reliably deploy service worker to millions of users and manage them at scale. Native apps have this first-class experience where they live on your home screen page or the app menu, and on a tap of an icon, you can open them up in a full-screen immersive experience. On the web, we have been stuck in a browser tab for a very long time. The good thing is that's changing with the service worker and web manifest. As Owen mentioned, now we have the add to home screen function. On Flipkart Lite, we make the add to home screen completely opt-in for the user. So as a user, once you engage and explore the web app, you can decide to press the install this web app icon, and it will open up the native pop-up, which will then add the icon to the home screen. From there begins the immersive experience. As you can see, as soon as I tap the icon, it opens up with a splash screen. There's a full screen experience. Gone is the URL bar. The interactions are smooth and fluid. We give touch feedback. When I search something, data loads in really quickly. And overall, the entire UI stays responsive. But that's not it. This web app is resilient to all kinds of flaky networks. So if I emulate the offline mode here, the web app still works seamlessly and allows me to browse my the cache product. And this works even if, thank you. The best part is this works even if the user tries to boot up Flipkart Lite on a flaky network. So here's an example of me trying to open Flipkart Lite on the airplane mode. It still opens up reliably at that consistent performance that we promise. And while we wait for the internet connectivity to restore, the user can still interact with the web app and browse previously cached content. This keeps the user engaged. And as soon as the connectivity comes back, the full functionality is restored. This is what we mean by reliable performance and network-resilient web apps. All right, so I did say we solved for SEO, but how exactly did we do that? Well, we just followed a couple of best practices. The first one was we treat service worker as an opaque black box. That means that application code is not all aware that a service worker exists or not. The second is that we embed SEO content within the app shells. Now, this might seem counterintuitive. What if my app shell of product page A gets cached, and then when I visit product page B, the service worker picks up the shell of product page A and serves me the content? Well, that might be true, but the good thing is web crawlers don't really have service workers. So web crawlers are going to make a network request every time, and with that, we can give them the relevant content. The third point goes without saying that you want to have cross-browser support for efficient and reliable crawling and indexing. Our main content, however, is still rendered via JavaScript and generated dynamically. With experiments at Flipkart, we have seen that the Googlebot does execute JavaScript and indexes the dynamic content. We've launched this just a couple of weeks back, and we are already seeing a huge upside in organic search traffic and a big surge in the number of mobile-friendly search results. When we launched Flipkart Lite, it started as a Chrome-only experiment. But from day one, we have always been committed to building a ubiquitous web app. Today, Flipkart Lite works on a wide spectrum of browsers with just a couple of more left to go. And this is essentially the theme of progressive web apps. You have a web app that works almost everywhere, and it starts in a browser tab. The more you interact with it, the more you engage with it. On more capable browsers, it transforms into a native-like experience. Fast forward today, we see over 45% users that shop The 45% users that shop on the mobile web are brand new customers for Flipkart. And not just that, we have over 40% monthly repeat users. Moreover, we have seen a jump of 70% in conversions from the user that browsed Flipkart from the full-screen immersive experience launched right from the home screen icon. And the best part is we have barely scratched the surface. There's so much more we can do with the mobile web, and we have an amazing team back at home in Bangalore, India, working very hard at this. Now, native apps have an incredible tool to reach out to their users, known as push notifications. Thanks to Service Worker, we can even send push notifications on the mobile web today. We're working really hard to bring this to Flipkart Lite soon. But to talk more about web push and Service Workers, I'd like to invite Nate Schloss from Facebook. Thank you.
Thanks so much, Aditya. It's really exciting to be here. My name's Nate Schloss, and I'm a software engineer at Facebook. I built out a browser push implementation, and I'm also working on our future use of Service Worker and rolling out Service Worker across our apps. At Facebook, we love the web. The web is cross-compatible. Users understand how to use the web, and there's low barriers to entry. The web is also fast. Navigating to a website can happen in the matter of seconds versus minutes to download a full program. As a mobile-first company, you might be wondering, why does Facebook care so much about the web? Well, mobile-first does not mean native-only. To have a successful, fully encompassing mobile-first strategy, you also need to include the mobile web as well as native. One might worry, all right, we're going to invest all of this time in a mobile web app, but what about the native experience? Well, the mobile web is growing right along native. When we see growth in the mobile web, we don't see any downsides going on in native. When we see growth in native, we see the mobile web grow right along with it. The platforms are complementary. They're not competing against each other. The mobile web plays an even more important role in emerging markets like India. In places where the barriers to download an app are high, maybe there's flaky networks, maybe people have a hard time understanding how to install Google Play, get online on Google Play, maybe you don't have a lot of data, so it takes time to, they can't download a full app. The mobile web is a lot easier. You can just click on a link, get to a site, and load it instead of having to download a full app every single time. The desktop web is also an area that's very important. The desktop web is an area of continued strategic importance to Facebook. Lots of people use Facebook on desktop, and it's an area that we need to make really awesome. We need to have it be a polished experience and continue to make it a really great way to use Facebook. So speaking of desktop, you might remember your first desktop computer. Maybe it was 1995, and you wanted to check your encyclopedia. So instead of browsing to a website, you would open your encyclopedia program. You would go, search what you want in your encyclopedia program, everything would be local, and you would get what you want. Let's say you wanted to play a pinball game. You would open your pinball app on your computer back then, and you would play your pinball game. But then we started seeing a shift to the web. Around 2000s, people stopped using native apps for everything and started shifting to the web for a lot of the reasons that I outlined before. The barrier to the entry on the web is lower. The web is fast, you don't have to download a full program. It's a lot greater. But then when mobile came around, we saw a shift back in the other direction. People stopped using the web so much, and they started using native apps on mobile. Now, why was this? So originally on mobile, the web was more of the desktop web just brought to a smaller screen. It was missing many of the things that made mobile great. The mobile experience and the desktop experience are pretty different. On mobile, you expect a real-time communication device. You don't expect the full desktop experience. And there's a lot of features on mobile that haven't traditionally been on desktop. For example, things working really well offline on flaky networks, and especially that real-time communication experience with push notifications. Push is necessary to be successful on mobile. You wouldn't use a messaging app that didn't tell you when you had new messages. You wouldn't use a calendar app that didn't tell you when you had a new appointment. And, for example, you wouldn't use a social networking app that didn't tell you when somebody commented on your status. Now, on the web, for the longest time, the best way to re-engage people was email. Now, email is not terrible. It can look pretty good, and users understand email. It's not so bad. However, the barriers to entry for email are pretty high. You have to type in your email address, then you have to go to your email program, click on a link, go back to the site. There's a lot of steps. Additionally, you can't get some of the real-time engagement that you can with push notifications. With email, if you're active, like commenting on a thread or in a messenger conversation, you have to keep going back to your email program to check what's going on. You don't get notified about anything in real time. With SMS, so we can also use SMS here, but SMS has a lot of the same barriers to entry that email has, in addition to being flaky and sometimes. So we knew that push notifications were a good way to solve this, and we also knew that they were very, very successful on our native apps. And we cared about the mobile web as well. And for the longest time, we wanted to bring push notifications to the mobile web. We wanted to do it so badly that we built private push notification implementations with UC Browser and Opera Mini. And just like we saw in our native apps, this was very impactful. Visitation grows up, engagement goes up. This was really, really great for the mobile web. So after successfully doing this in a private way, we wanted to start doing it in a standards-compliant way, in a way that would work everywhere, and just really well for everybody outside of the box. So when we heard that Chrome and Mozilla and others were working on doing a web push API with service workers, we were really, really excited to build a notification implementation there as well. So what does this look like? Well, when a user browses to Facebook, they can opt in to get push notifications. Once they do that, let's say somebody posts on their wall. So somebody tags them in a post, they can click on a notification, and they get to the content right away. This is really similar to the native experience. In many ways, it looks identical to the native experience. And it's the experiences that users know and expect and like. This is the way to do notifications on mobile. So from a technical side, as Owen was saying before, setting it up isn't too bad. When your user opts in for push notifications, you get an endpoint. You send data to this endpoint. In this case, it's going to be Google Cloud Messaging. Now, GCM is going to have a persistent connection with browsers. So it has this persistent connection, and it sends a push event with the data that you sent to it before to the browser. The browser knows which service worker to wake up for this push event. It gives the push event to the service worker. The service worker takes the data and makes a notification. It gives the notification to the browser, and the browser can then go ahead and display notification to the user. Now, if you're doing this on the most modern browsers, you get push notifications with data. However, if you're trying to take the long tail of the web, not everything supports push notifications with data. So you also want to set up push notifications that can work in situations without payloads. Doing this is just one additional step. It's not too bad. So just like before, you have your push endpoint, and you send a request to it. However, this time, you don't have an encryption key, and you don't send data. Just like before, you have your push provider, which is there, and it has a persistent connection with the browser, and sends your push event to the browser. Just like before, the browser knows which service worker to wake up for this push event, and it wakes up the service worker and gives it the push event. However, this time, your service worker doesn't have any push data. So it has to go back to your server, fetch the data, and then it has the data so that it can use to display notification. It constructs the notification, just like before, gives it to the browser, and the browser can display the notification to the user. However, I should note, in this scenario, there's one other thing you want to think about. That fetch request back to your server could potentially fail, but the service worker still has the push event. As part of the contract to getting push events in a service worker, you're promising the browser that you're going to go ahead and actually display notification. If you don't, many browsers will apply a penalty, and some browsers will actually show an error message notification. This error message notification is not a good user experience. It looks really bad. So you want to always have a backup notification ready in your service worker for if that fetch to you fails. So as we rolled out Push at Scale, there are many lessons that we learned along the way. One of these is when it comes to clicking on notifications. The problem of clicking on notifications might seem pretty straightforward. You click on a notification, and it opens a new browser window. So let's say you're in an active messaging conversation. I click on a notification, it opens a new browser window. Now the next message comes in. I click on a notification, and it opens a new browser window. Now another message comes in. I click on a notification, it opens a new browser window. As you can tell, pretty soon you're going to end up with a lot of browser windows open. It becomes really, really hard to use Chrome because you just can't find the tab you want. Maybe things could be a little slow. It's not a good user experience. All right, so how do you solve this? Well, maybe you click on a notification. Now the service worker checks if there are any windows open. And then if there are, it asks that window to navigate to the place it clicked. Or if there's no windows open, it opens a new window. This brings some other challenges, though. Let's say that you have a site that users can engage with. Maybe they're in the middle of typing a comment or a new post. And they click a notification, and then the window navigates, and it blows away their post they're in the middle of writing. That's also not a good user experience, because now you've just deleted what the user was in the middle of doing. So to solve this, we came up with a solution that's not too bad. So somebody can click on your notification, then the service worker is going to get a notification click event. Now, what the service worker will do is it'll check if there's any windows of your site open. If there aren't, just like the first scenario I outlined, it can go and tell the browser, hey, browser, please open a new window to my site. And the browser can open it. Pretty straightforward. Now, this case gets a little more interesting. Let's say you have a window open, and somebody clicks on your notification again. Just like before, the service worker gets a notification click event. However, this time, the service worker is going to check and see if there's any windows of your site open. If there are, instead of posting a message to the browser, it'll send a message to the window saying, hey, window, can you please navigate to this URL? The window can then either say, yes, I'm going to go navigate, if the user's not in the middle of writing content, in which case the service worker can say, hey, browser, please focus on this window. Or the window can say, hey, the user's in the middle of writing a post. I can't navigate right now. In that case, just like before, the service worker can go ahead and open a new window. We found that this was the best compromise between not overwhelming the user with too many tabs of the same site being open, but also not blowing away what the user was in the middle of doing. So in a similar vein, when we were first building this, I had notifications on for every single platform. At the beginning, this wasn't too bad. It was just Facebook, the native Facebook app. So I would get a notification from Facebook, my phone would shake, I would see the notification, not too bad. But then once we hit every single platform, this got to be a little overwhelming. So I get my notification from Facebook, my phone just shook, I'm pulling out my phone, now my phone shakes again, I get a notification from Chrome, I'm maybe looking at the notification from Chrome, trying to pick between Chrome and Facebook, then I get another notification from Opera, then maybe a little bit of time later, I get another notification from UC, so now I have my phone out, I'm looking at this. Then my computer makes a sound, and I get a notification from Chrome on my computer. There's a lot of things going on. I'm just like, what is happening? So solving this is kind of straightforward. Only send notifications to your users on the interfaces that they frequently use. Just because you can send notifications on every interface does not mean you should. Pay attention to where your users are engaging with your site and using your app, and notify them there. In a very, very similar vein, you want to make sure you don't send display too many notifications at once. Let's say you're in a Messenger conversation, and I get one notification for another message, then another notification comes in for the next message, then another notification comes in for the third message, then I get another notification for the fourth message. And if I show a different notification on the screen each time, pretty soon the screen is just full of messages, and it's very, very hard to use my computer or really even engage with any of the messages because there's just kind of there's a list that's just constantly filling up. To solve this, you can use tags on service worker notifications to replace previous notifications. Think of tags as a slot. You can say I have tag A, slot A, and then if there's no notification in the slot, the browser will just display a new notification there. But if there is already a notification there, the browser will replace the existing notification with the newest one. This way you can make sure to not overwhelm the user by displaying too many notifications on the screen at the same time. Another interesting case we ran into was accidentally downgrading clients. When we push out new code on Facebook, we don't roll all of our servers to the newest version 100% all at once. We test the newest version of our server code for a little bit before we roll out the entire site. For this example, let's say we have version 1 rolled out at 80% and version 2 rolled out at 20%. And we have our service worker and the entry points to Facebook. So the browser wants to go ahead and update the service worker. It hits Facebook and says, hey, Facebook, can I have the newest version of the site? We're like, yeah, here you go. We hit version 2 this time, and we give the browser the newest version of the service worker. This is great. The user's fully up to date. They have the latest experience. This is really awesome. However, let's say sometime later, the browser goes ahead and updates the service worker again, just like before it hits Facebook, but this time we serve the service worker from version 1. So this is not the best experience. Let's say we save data in a new format in version 2. We'd have to make it backwards compatible with anything that was going on in version 1. Also, it means that the service worker is going to do an update that it shouldn't do. The service worker is going to be in the update state way more often than it should, which does not lead to the best user experience. To solve this, what we did is we started looking at the current version during the install event. In the install event, we would check to see if the currently installed version of the service worker was greater than the newer version. If the currently installed version is greater than the newer version, we throw an error in the install event, and we just don't let the install event complete. This means that the user is always going to be on the newest version of the service worker, which makes developing for service worker a lot easier, and it leads to a greater user experience overall. So after polishing and perfecting the user experience with service worker and push, we rolled out Web Push and started looking at impact. So it's been about a year, and a year later, we're happy to say that Web Push continues to drive significant impact for Facebook. Mobile was right in line with what we were expecting. Web Push on mobile is great. We knew that it was great. It fit our native experience really well. We kind of knew that Web Push on mobile was awesome, and we saw the engagement we were expecting. Daily month of active users increased, commenting increased, engagement increased. It was really awesome. On desktop, we were a little bit worried. It was many users' first time getting push notifications on desktop. The desktop experience is different than mobile. People don't always expect to have real-time communication on their desktop just like they do on mobile. We were very, very happy that this had great impact on desktop as well. Daily month of active users increased, commenting, all the things that we would wanted to increase, increased. What we saw was that users kept it on, and they really enjoyed the experience. It turns out that people like getting notifications where they're already using Facebook. If you meet a user where they are, it's just a greater experience for everybody. So now that we rolled out Web Push, we're starting to look into and investigating where we can use service workers elsewhere at Facebook. Today, loading Facebook is often blocked on the network. What we try to do when we load Facebook is we do a little bit of work on the server, and then as soon as we can, we push it out on the network and let the client do work as soon as it can. Then in parallel, we do a little bit more work on the server and try to push that out to the network as soon as we can. What this does is we're taking full advantage of everything that we can across the stack to try to get the user Facebook as quickly as possible. However, if the network is flaky or slow or something's going wrong, this can just block the client from being able to do anything. The client doesn't get Facebook at all. Maybe it takes a long time. A lot of the optimizations that we can get by doing things in parallel just don't apply anymore. With Service Worker, can do much better. Like Aditi said, with Service Worker, we can make sure that we already have the shell of the app loaded. We can start doing work on the client before we even hit the network and before we even hit the server. The client can start doing work to display the site. Then all it has to do is fetch the content that it needs to display this piece of content instead of fetching an entire app every single time you hit the site. So we can start doing work in parallel even earlier and parallelize across more of the stack. Another experience that we can get is being able to run an app totally offline. Now, offline dinosaur is great. He's super cute, but really it's time for him to go extinct. Native apps can work offline. When you open a native app, you don't see, and you don't have an internet connection, you're not going to see offline dinosaur. You're still going to see an app experience. And this is what we should be able to get on the web, and now we finally can. At Facebook, we're already really starting to invest heavily in service workers, and we're very excited about their future. Starting this week, we began testing offline mode on Messenger.com using service workers. We're using service workers on WhatsApp Web to make the site load much, much quicker. And as I talked about before, we're using service workers to power push notifications on Facebook. Service workers make native experiences possible on the web. At Facebook, we're very excited about the future of service workers, and we can't wait to explore their potential in the months and years to come. Now, to wrap things up, Owen's going to come back on stage.
Great job. Thanks, Nate. So I'm really excited about all of the momentum we're seeing in the community around service workers and progressive web apps. I was really happy to steal this slide from Rahul's Mobile Web State of the Union yesterday, which shows all of the different companies that have either already shipped progressive web apps or are investing in progressive web apps. And it's not just Chrome. This is a journey that a number of the browser vendors are taking together. And here you can see some of the tweets and posts from a number of the other browser vendors about service workers and progressive web apps. We've been really excited to see the momentum in this community, and I encourage all of you to get involved. Ask and answer questions on Stack Overflow, post your libraries and your pull requests on GitHub, and tweet at us on Twitter. With service workers, we need to rethink web development. It's now possible to build high-performant, engaging experience on the web. And all of these features are available in production today, and they work progressively. And so I encourage all of you to go back home and join Facebook and Flipkart in using service workers at scale. Thank you.